So in this talk I'm going to describe what we've been doing under Work Package 4 to develop the MOOC, Massively Open Online Course in Supercomputing. So first of all I'll do a bit of the history. The MOOC has been in development, or at least we've had an idea for it a long time, and original plans for the MOOC were developed before the target platform, the delivery platform, was decided. So there's a number of platforms available. For example, I've heard of Coursera. Praise has chosen to use FutureLearn, but when we initially devised the MOOC, the platform wasn't finalised. So I'm going to go through what the curriculum, learning outcomes and delivery method, what the plans were before the platform was finalised, and then any changes that were required to that once FutureLearn was selected as the platform. So the planned curriculum was to have week 1, it's a 5-week course, around about, I guess, 3 or 4 hours per week of engagement from the students. And the MOOC is called Supercomputing, not Supercomputers. The MOOC covers both hardware, software and application, so it's not just the hardware, but it's how they're used and what they're used for. So the first week though is going to very much cover the hardware, cover sort of top 500 list, talk about a bit of history and how fast these computers are. Week 2 goes into a bit more detail, saying how supercomputers, parallel computers, get their power from large numbers of CPU cores. It'll talk about distributed and shared memory as well. And the reason for that is I think it's interesting for people to understand how commodity machines, like that their own laptop or their games machine works, and so that's important to understand shared memory as well as distributed memory. Week 3 we talk more about software, parallel computing, we talk about message passing for distributed memory and the shared variables programming model for shared memory, or you might think of those as MPI and OpenMP. And I illustrate those with a very simple model, the traffic model. It's a 1D cellular automaton, which I think is very useful for illustrating particularly message passing programming. Just to say here, this is not a programming course. We don't expect that people can program in any language. So we're going to talk about things at conceptual level. However, we would like people who can program to get some more out of the course. So it's kind of a balancing act between having enough technical information, not having too much technical information, not using too much jargon, so the people that can't program still understand the concepts and what's going on, but hopefully in enough depth so that those who can program understand how programming fits in. Week 4 we go on to computer simulation, telling people how numerical simulations are used in modern computational science, and we'll illustrate that with weather forecasting, climate modelling. And the final week is basically a bunch of case studies from a whole range of areas, illustrating the benefits of supercomputing. We'll also talk a bit about the future, about exascale and a bit about quantum computing, but the main focus of week 5 is always meant to be case studies. The planned learning outcomes, we wanted people to understand how supercomputers get their performance, understand that they're built from simple processors, but many of them, to understand shared and distributed memory architectures, and to be able to compare how a modern supercomputer compares with a desktop PC or games console. Also to understand how computer simulation works. They'll understand a very simple cellular automaton model from the traffic model, and we'll get them to look at these simple problems like stellar automatons and look for opportunities for parallel processing to identify where, for example, how you'd apply the shared variables model for shared memory programming, or how to apply the message passing model for distributed memory. So there's not actually a learning outcome here to understand the different programming models that probably should be actually, as well as understanding shared memory and distributed memory computers. We want to understand the associated programming models, again at conceptual level. Explain the limitations of parallel computing, that's looking at scaling behaviour when the overheads outweigh the benefits, and then from the case studies to give examples of scientific areas where computer simulation is used. Now, our original planned delivery method had been informed by a few MOOCs we'd looked at, and we planned to reuse a lot of existing material, repackage but reuse the material. So for example, we already have been running for over a year, online courses in data science and high performance computing. These are fully online courses, quite substantial 20 credit courses, which corresponds to about 10% of an MSc, more than 10% of an MSc, that students do online. And this year we actually have about 25 students on the data science course and 7 or 8 students on the high performance computing course. That is a programming course, or at least people compile and run programs and develop small programs, but we're going to use the introductory material from that. And we plan to record a number of short 10-minute videos, maybe with talking heads standing in front of a board. So that was taking material from, you can see where the URL is, EPC AC UK online courses, so these accredited, university accredited, fee-paying online courses. But we plan to use the experience of developing those to develop a number of lectures. However, Future Learn was picked, and we didn't change the curriculum or the learning outcomes. The aim of the MOOC was the same, but the delivery style we had envisaged was not compatible with Future Learn. Future Learn is very much based on a large number of small steps. A step can be an article, a quiz, a discussion topic, and they may have external links. A step may be a video, but they're the idea is to have very short 5-minute videos to reinforce key concepts. They're encouraged, but not for major content delivery. So the idea is that videos are there to pick up on or elaborate on particular concepts. And so that didn't fit our original, more classical recorded lecture style. Now, in fact, this Future Learn House style is very suitable to this MOOC, being an introductory MOOC where we're not expecting a very high level of technical expertise. A lot of existing Future Learn courses are pre-access to university, they're entry level, trying to encourage people to look at going on to take higher level courses. I should say that Future Learn has emerged out of the UK's Open University, which has been offering degrees, fully distance learning degrees for many decades. And so, they're looking at this. Their original idea for this was a way of promoting their courses. So these are pre-university access, pre-university level courses. So the house style is good for our MOOC. Unfortunately, we needed less content overall than initially envisaged, so our MOOC is less content heavy because that is the Future Learn style. But we required more new material. We had to be a bit more innovative about the material and pull in things and develop new ways of presenting things. So just to show you the current course, this is live and online. You can go to the URL futurelearn.com/courses/supercomputing. You will see our course there and you can join. You see it starts on the 6th of March. So I'm just going to give you a few, that's the public page. I'll just scroll down a bit to show what else you could see there. There's a short promotional video which my colleague Manos put together based on mainly existing material from Praise, Dare to Think the Impossible, and contributed things we got from Barcelona and I think from Jülich perhaps. It's a short 1.5-minute video. About the course, this was text suggested by Future Learn, but very much taken from our pitch to them. Then you can see the general outline. They've given some sort of summary of what our 5 weeks are: supercomputers, parallel computing, computer simulation and case studies as we originally envisaged. And I'm there as lead educator. It's mainly been developed by us at University EPCC University of Edinburgh. We've also had a lot of help from Zheng Zhao at Surf Sara as well. So it's a collaboration between us and Zheng at Surf Sara. So this is what you won't see this now because this is only when I can go in as an educator and see what's online, but you can't see this yet because the course hasn't gone live. But this is, say, week 2. A week comprises multiple activities, typically about 3. So there's a top activity here about shared memory programming you can't see. Then the second activity, which corresponds steps 2.6 to 2.9, is about connecting multiple computers. That's distributed memory. And you can see there we've got a couple of articles, we've got a discussion, and we've got a quiz. And there are going to be videos here as well, but the videos are still getting finely polished. We haven't uploaded a lot of videos yet. But that would be a standard, a typical week might be, say, 3 activities, each with half a dozen steps, articles, discussions and quizzes. And an article, the quizzes are multiple choice quizzes are quite standard. The videos, I'll show you an example later, but a typical article is quite short, maybe 50 to 1,000, 750 words max. You'll see I've put a couple of examples there. One on distributed versus shared memory, which is the end of that week I just showed you, where we compare the two. And then we're asking people to do a simple parallel calculation. We're asking people to take adding up lots of numbers and try and consider how you might parallelize that. So and I think you can get a feeling for the look and feel of what Future Learn looks like. We've also got videos. We had very ambitious ideas for the videos. We'll come back to. We've gone for quite simple presentation, just simple blue screen videos, where I'm sitting there in front of a blue screen with a table and this is illustrating this cellular automaton, this traffic model, which I've illustrated by moving pawns on the chessboard, and we've just put a backdrop in, which is actually the main course logo of a supercomputer. And so we have a number of these videos of me talking and pointing at things, but they're not as ambitious as we'd originally envisaged, but I think they're good enough. So what next? Well, we have to have an initial draft version available within just over a week, by February the 7th, and FutureLearn, our contact there, Ross Baxter, will review the content and give us suggestions. We hope to have a complete course there. The only thing which might not be complete is the videos may not be subtitled, I'll come back to that, or they might not have been fully converted into topped and tailed with the FutureLearn style, but it will be enough for Ross to give us some feedback. We'll also use that opportunity to look at it, take a step back and look at it as well. Also the same week we're having a meeting with FutureLearn to get advice on how to support the learners during the programme. This is something very unknown to us. I don't quite know how it works. It's quite like touch. Learners are supposed to support each other through the discussion forums, but you want to monitor them and chip in every now and again if people are getting the wrong idea or want to give people help. So we have some information. We have some colleagues who've run a MOOC on Haskell programming, which is a functional programming language. We've chatted to them about how it works. But it is largely an unknown quantity, and largely I think depends on what you're teaching and how you're teaching it, so that's going to be a bit of an unknown. We go live on the 6th of March, so please publicise that URL, futurelearn.com/courses/supercomputing, to anyone you might know, and they can sign up. What's the interest so far? Well, we haven't done a lot of publicity. That will come, I think, in the last month. That seems to be the way FutureLearn like it. They say that with a month to go, that's when the big push comes. We already have almost 1,000 people as of 24th of January. There were 950 people registered. The platform gives it some interesting demographics. I've just looked here at age profile, so you see we're dominated really by people sort of, I guess, 18 to 30 seems to be the main age range, and quite a few in the upper. So quite a wide range of ages. We'll see what happens. It doesn't take much to register interest in a MOOC. You just click a button. So it'll be interesting to see how what numbers we get at the start, and how the demographics progress as the course evolves. So to summarise the plus points, I like FutureLearn. The style is clean and nice. You upload text and it formats it into this quite nice look and feel. It's quite easy to upload material. It's easy for me to say that. It's my colleague Veronica that's done it all, but developing the show has been enjoyable. It has been tough. It's been quite a lot of work. FutureLearn have a subtitling service which is done by people, not automatically. We've done a few tests and it seems to work quite well. And also the most important thing is you get the subtitles back in a plain text format. So if the subtitles are wrong, it's just text editor and you edit them. It's not some enormous point and click GUI. You can just edit the subtitles as a text file. And then it's a standard format which is merged with the video when it's actually shown. Now the minus points, as I say, it has been quite a lot of work. You have to be very careful with copyright. So we've actually used, for all our images, we've used iStock photos. It's a pretty standard image commercial repository. The university has a license, and we can use those images as we like. And there's a lot of Creative Commons, non-commercial material out there. We've avoided it because although the MOOC is free, you can sign up for free. FutureLearn make money selling completion certificates, so it's not immediately clear to me what the state of Creative Commons non-commercial material is for FutureLearn. We've not really got a clear answer about that, so we've tended to avoid it. Making videos is hard without professional help. We had an extra budget of about €1,500. We used that for cameras, microphones and software and such like. If you'd wanted to do professional videos, it would be an order of magnitude more expensive. Luckily we have a local enthusiast. Colleague Manos Varsarakis has done quite a bit of audio production and is keen on this kind of thing. I think he's done a good job. To be honest, given this is the first time we've ever run a MOOC, I think paying a lot of money for very professional production might have been a mistake, because who knows if you're going to carry on using the material. So I think we've got a good compromise here, where we've got good quality material which is usable, and if we wanted to take the MOOC forward, we could decide to re-record some things in a different way, or do more videos or something. But it is quite difficult without professional help. The future, typically FutureLearn MOOCs are rerun every 3 or 4 months, and so again, future runs would hopefully be much less work. We would just have to support users. Of course, there's another MOOC being developed on big data by Leon and colleagues from Ljubljana. So my question is, for the other Work Package 4 partners, what MOOCs are you planning, you can ask us. But we've done two very different MOOCs. We will have done two very different MOOCs by the end of 4IP. There's now a lot of experience from ourselves and Leon on doing this, so I'd like to hear what ideas for the MOOCs that other partners are planning to produce.